Welcome to the first lesson of the second semester. This is direct and inverse variation, and I am recording this video not in front of the class, so it won't have the typical pauses that exist when I'm talking in front of a class. So if I'm going too fast, or if I give you a you try and you need to actually do what I'm asking you to do, you might want to hit pause and then hit play when you're done. So direct and inverse variations are particular kind of relationship between variables that we're required to know. This is according to one of our SOLs. And we've actually dealt with one of them already. We did direct variations when we did the chapter on graphing linear equations. But we didn't do everything we could have done with it because I knew we had to do inverse variations and that we would get to it at that time. So we need to know what is a direct and what is an inverse variation, be able to use those. You can see here, because it's the first time we're seeing this for the semester, that I would expect that we're going to have 2 quizzes during this chapter. The first quiz will be on the 5th, which is Friday for 1A, or Monday, next Monday for 3B. And there will be another quiz after that. And the test, if everything goes according to plan, will be on the 18th and 19th of February. So direct variation, you can hear that referred to in different ways. Okay, it might say, and usually textbooks say y varies directly with x, but the SOLs say y is directly proportional to x. So either one of those wordings should mean the same thing to us, and that is a relationship which is usually expressed as y equals kx. And k is a constant, means it doesn't change. X and y are variables, right? Our equation is going to have x and y variables. There will be a number in front of x, and that number is a constant. We don't know it when we start the problems. That's why we use a letter to represent it, but it's a constant. K. So compare y equals kx to y equals mx plus b. Right? We've dealt with that before. Right? That's the slope-intercept form of a line. Now, what's different with y equals kx? Okay, well, for one thing, you have k as the coefficient of x instead of m, which means that the k equals m, meaning k is the slope, right? And because you don't see anything after the kx term where the plus b would be, well, that just means that the b equals 0. So the y-intercept is 0. If you graph this equation, it's going to go through the origin. Now, direct variations are linear relationships then. Right? We would expect if we graph a linear relationship, we would get a straight line going through the origin, and the slope of that line would be the k, the constant of variation or constant of proportionality. So the first thing is, how do we know whether an equation represents a direct variation? Well, like we said, if it is a direct variation, then the y-intercept is 0, meaning there is no term after that. So if we put these equations into slope-intercept form, if there is no b, then it's a direct variation. So in this first problem, if I subtract 2x from both sides, I get negative 3y equals negative 2x. Now I'm going to divide both sides by negative 3, right? And I get y equals positive 2/3 x Please keep that in mind, because too many of you still either don't simplify a negative divided by a negative, or you think that it's just one negative, and it's not, right? Negative signs cancel. Okay, so this is a direct variation because there is no term following the x term, right? That means b equals 0. This is a direct variation. And we can say now that the k is the coefficient of x is 2/3. Okay, let's try to do the same thing with the second. Again, in order to know whether this is a direct variation, let me put it in slope-intercept form. Let me add x to both sides. Y equals x plus 4. And now you can see that b does not equal 0. So this is a linear relationship, but it's not a direct variation. Not direct. So you try to do the same thing with these three equations. Tell whether or not they are direct variations. And if they are direct variations, then say what is the constant, what is the k. And go ahead and hit pause at this point. And I'm going to go ahead and do this, so hit play when you're ready to go. So the first one, if I solve it for y, I get y equals x plus 1. Okay, so we can see that b does not equal 0, so this is not dv, not direct variation. This one, if I solve, it'll be y equals negative 2x. So this is a dv, this is direct variation. K equals negative 2. Okay, this one I could take a couple steps, right? That'll be negative 5y equals negative 4x, which means y equals positive 4/5 x. Again, because you don't see a term, a constant term after the x term, that means b equals 0. So this is, again, this is a dv, direct variation, k equals 4/5. Okay, the graph of a direct variation equation passes through the point 4, 6. Write the direct variation equation and find the value of y when x equals 24. So we need to come up with the equation of a line that it's a direct variation and it goes through the point 4, 6. Okay, well, let's see. Just to see what I'm looking at here, the point 4, 6 is about right there. And because this is a direct variation, I know that this line also goes through the origin. 0, 0. So right away I know that the y-intercept of this line is 0. All I need to do is find the slope, right? The slope will be the k. So between these 2 points, if I use my slope formula, right, I would get 6 minus 0 over 4 minus 0, which is 6 over 4. Simplified, that's 3/2. But in our direct variation, y equals kx, right, the m is the k. So I can say that y equals 3/2 times x. Okay, now we can answer the question. Find the value of y when x equals 24, right? So when x equals 24, we get y equals 3/2 times 24. And that is y equals, the 2 goes into 24 12 times. So this is 36. So remember, if you know 1 point, if they give you 1 point, but they tell you it's a direct variation, then you actually know 2 points. And you don't need to find both m and the b. The b is 0, just find the slope. So try to do the same thing with this. You try. The graph of a direct variation passes through the point -1, 2. Write the direct variation equation and find the value of y when x equals 30. Right? Please do not look at a problem like this and see the first 2 words are graph, the graph, and think that you're supposed to graph this. You are not. You are writing an equation. That's the point of this. So go ahead and hit pause, and when you are done, hit play and see whether you got it right. So the point -1, 2 is here. Goes through the origin. That's the point 0, 0. And there's our line. Again, I don't have to draw the line. That's not actually what I'm being asked to do. And eventually, you're going to see that you probably don't need to draw the line to calculate this slope. It's just going to be 2 divided by -1. But I'll go through it anyways. So the slope of this line is 2 minus 0 over -1 minus 0, which is 2 over -1, which is -2. So this equation is y equals -2x. Okay, now find the value of y when x equals 30. Y equals -2 times 30, which is -60. Okay, here's going to be a word problem. And I'm trying to think. It's asking us to do 2 things here, 1 and 2. But it's actually constructed like these problems are almost always constructed. And you're going to deal with this in Algebra 1, and you do a lot more with this in Algebra 2, and then these questions are always on the SAT. No doubt about it. And they're almost always worded exactly the same. Not worded, but constructed. And we'll see what that is. In this particular problem, it says the number S of tablespoons of sea salt needed in a saltwater fish tank varies directly with the number W of gallons of water in the tank. A pet shop owner recommends adding 100 tablespoons of sea salt to a 20-gallon tank. Right? So here's our 2 tasks. Write a direct variation equation that relates W, remember that was the gallons of water, and S, that was tablespoons of sugar, of sea salt, sugar. How many, and then answer this question. How many tablespoons of of salt should be added to a 30-gallon saltwater fish tank? Okay. So step 1 in all of these problems, they're going to tell you what kind of variation that you have. And you are going to write down the general formula for that kind of direct variation. Now, in this problem here, the wording said varies directly. right? Varies directly, which we said already. Okay, well that means y equals kx. The only difference here is we don't have y and x. We have s and w, right? In this problem, they gave us two different variables. The k is still the same, but that's all this is supposed to represent. Let's write down the most general form of a direct variation, s equals k times w, where s and w are variables, k is a constant. Okay, so that's the first step. Second step, they have to tell you a data point, meaning values of the variables that go together in one point, so that you can substitute for the variables and solve for the k. In this case, it says the pet owner recommends adding 100 tablespoons of sea salt to a 20-gallon tank. Okay, well, since the S represents the salt, that's like the Y variable. That's why I'm putting the 100 here as the Y coordinate in a point. And the 20, which represents the W of gallons, the W was like in place of the X. That's why I'm putting the 20 here. So we know that this is a point 20, 100, and we can substitute for both of those, 100 and 20. And now the only thing we don't know is k. So you can solve for the k. Maybe if it makes it any easier, you could write it like 20 times k equals 100. Solve for k. Divide by 20. And k equals 5. So the second step, after having given you the kind of variation, they give you a point so that you can solve for k. And now you can update the variation, okay? This is what we know. We don't have to use k anymore. We know k. K is 5. So this is S equals 5W. So the amount of tablespoons of sea salt that you're going to use is going to be 5 times the number of gallons of water. That's the direct variation relationship. And that is the first part of that. Write a direct variation equation that relates W and S. Okay, the last part is, now that you know the direct variation relationship, the equation, then you can answer a question. And the question is, how many tablespoons of salt should be added to a 30-gallon saltwater fish tank? So this 30 is going to go here, here. And it looks like S equals 5 times 30. You're going to add 150 tablespoons of salt. Hopefully you're not going to do that 1 tablespoon at a time. That would take a long time. What was I going to add here? I think there will be a homework problem that deals with this, but there's not a you try right now. When you get to the point of doing your homework, if you need to look at something to see how we did it, then watch the video, have it open while you're trying to do your homework. Okay, now we can move on to inverse variation. Now what we did with direct variation, that came from chapter 4. We had actually talked about that concept, direct variation, before when we did chapter 4. Okay, this we didn't. This comes from chapter 12, I believe. Okay, now an inverse variation could be worded in a few different ways. It could be y varies inversely with x. Or on the SOL, it's a little more likely that it'll say y is inversely proportional to x. I'm trying to see whether I'm actually recording here because I've lost my little icon here in the bottom. But when I click on this, it says recorder is recording. Okay, that's good. I'm going to keep going, assuming that we're getting it. Or it could say that x and y vary inversely. You can't say that for a direct variation. You can't just say x and y vary directly, because it would change the value of k, whether or not you write it as y equals kx or you write it x equals ky. It would change it. When you write y equals k over x, and honestly, it wouldn't make any difference if I wrote x equals k over y. The k would be the same. So this one is unique to an inverse variation. And still the k is a constant of variation or a constant of proportionality. Okay, tell whether the equation represents a direct variation, an inverse variation, or neither. Well, before we try to say that, I would solve for y, because that would make it look like the general form of either one. Like this one here, if I solve for y, it looks like y equals 4 divided by x, right? I divided both sides by x. And that's an inverse variation. This one, if I solve for y, multiply by 2, then I've got y equals 2x. And that is direct. This one, remember, a direct variation, the y-intercept is 0, so you would not have this term. So because of that, it's not an inverse variation. It's not, the x is not in the denominator, but it's also not a direct variation because it has a y-intercept which does not equal 0. So this is neither. I'm going to try to pause this. Okay. Well, I never did that. It's working a little different than it's done before. Okay, here's your you try. Tell whether these are direct, inverse, or neither. Hit pause, and when you are done, hit play to check your work. Okay, this first one, this is already in the form of an inverse variation. This is not. Let me solve. Divide by 4. And that is direct. It's a constant times x. And this, if I solve for y, right, subtract 5x. And because we have negative y, we either need to multiply or divide by negative 1. But remember, we have a property for that, right? What is the multiplication property of negative 1? It says that when you multiply by negative 1, it changes the sign, right? So it becomes positive y equals positive 5x minus 3. And in either case, because of this, it is neither. Okay, so here's the same kind of problem we did the word problem with the direct variation. And again, this is very, very typical. They got to tell you what kind of variation you've got. Then they're going to give you enough information for you to be able to solve for the k, and then you're going to be able to answer a question. Right? So x and y vary inversely. So they just told us y equals k over x. And y equals 6 when x equals negative 3. Okay, y equals 6 when x equals negative 3. Okay, with that much information now, I can solve for k, right? Since 6 equals k over negative 3, if I multiply both sides by negative 3, then the negative 3's cancel. K equals negative 3 times 6, right? K equals negative 18. So here's our equation. Y equals negative 18 divided by x. Okay, so again, actually I kind of confused this a little bit. I mean, I jumped ahead to the second step. So the first step was writing this down. The second step was using the point so you can calculate k, and so this becomes the result of the second step. And the third step is answer the question, which is, done that. Find the value of y when x equals 4, meaning take that and put it there. Y equals negative 18 divided by 4. And you have a calculator right in front of you if you have to. As a fraction, it could be negative 9/2. As a mixed number, it could be negative 4.5. As a decimal, is negative 4.5. So try to keep these steps in mind, right? Write down the variation. Use the data to find the k so you can fill in for the k, and then answer the question. So let's try to do this again. You try, hit pause, try to do just what we did on the last one. Hopefully you were taking notes, so at this point you could go back to your notes and then just try to repeat the pattern with this information. Okay, so hit pause and hit play when you're ready to see the results. So x and y vary inversely. Y equals negative 2 when x equals 12. So k equals negative 24. So here's our equation. Y equals negative 24 over x. Remember, in order to solve this for k, you multiply times 12. And that's where you get negative 24. Okay, now you can answer this last question. Find the value of y when x equals negative 3. So we're going to put negative 3 here. Y equals negative 24 divided by negative 3, which is 8. So we're supposed to be able to tell by looking at data whether or not the data represents a direct or an inverse variation. And it's convenient to do that is to rearrange our equations just a little bit, right? If in a direct variation, y equals kx. If I solve that for k, meaning divide both sides by x, what we come up with is k equals y divided by x. Now, x and y are variables. They are going to change. There's going to be infinitely many pairs of coordinates, x and y. But what doesn't change, because it equals a constant, y divided by x equals a constant, is the quotient. So if you want to check for a direct variation, divide all the y values by the x values and see whether you always get the same thing. If you do, it's a direct variation. For an inverse variation, right, you start with y equals k over x. Again, solve for k. In this case, multiply both sides by x, and you get k equals x times y. So again, x and y will change. But what won't change is their product. If you multiply x times y, it will always be a fixed number. So the product xy is constant. So if you want to check to see if data represents an inverse variation, then check the products of the x coordinate times the y coordinate. If you always get the same thing, then you know you've got an inverse variation. Now, if you've checked for the direct and it's not direct, and you've checked for the inverse and then it's not inverse, then it's neither. So it's possible to get one of three answers by doing this kind of problem. So let's tell whether the table represents a direct variation, an inverse variation, or neither. Okay, so let me check for direct. Okay, if a direct variation is here, that it should be that y divided by x is the same thing. Let's see, 2.4 divided by -5. Let's see, that'd be -0.48. You can do this with your calculator. I'm just doing it in my head right now. How about this one? 4 divided by -3. If you put it in your calculator, you're going to get -1.3 repeating. So right away, I'm checking the quotients, and these are not the same. So that's not going to be a constant. So let's stop checking it. It's definitely not direct. Okay, let's check the products. Okay, -5 times 2.4, I'll do it on top. -5 times 2.4 is -12. -3 times 4 is -12. 4 times -3 is -12. 8 times -1.5 is -12. So in every case, the product x times y was the same. So we can say, based on this, this is an inverse variation. Okay, let's try the same thing here. Start with a direct variation. Check the quotient, y over x. 8 divided by -4 is -2. 4 divided by -2, -2. -2 divided by 1, -2. -6 divided by 3, -2. Okay, well this time we checked the quotient and every one was the same thing, which means direct variation. Now, once you've checked, if you've checked this correctly, the thing is you just found the k. If this is an inverse variation, then we know that the k is -12. So really, it's y equals -12 over x. And here, that is the k. So y equals -2x. So I guess it's time for you to do one. Again, hit pause, check the quotients to make sure if it's a direct variation. Check the products to make sure if it's an inverse variation. And if neither one of those works out, then you just say it's neither. So again, hit pause and hit play when you're ready to go. So I'm gonna do y over x underneath. 3 divided by 1 is 3. 6 divided by 2 is 3. 9 divided by 3 is 3. 13 divided by 4 does not equal 3. So this is not a direct. So it tells you need to check all the pairs, right? Because it looked like it was constant for the first three, but then it was not the same thing for the fourth xy coordinates. Okay, now if I try xy, for the first 1 times 3 is 3, 2 times 6 is 12, and those are not equal, so this is not inverse. So it's neither. And one more problem, a word problem. Again, we're not going to do a U-try like this, but you're going to get a homework problem like this. So you go back and watch the video if you need more help to do this. try to keep in mind the 3 steps that we've used to solve the other problems like this. Okay. First, describe the variation or write it down. Second, find K. Third, answer question. So let's read this. A theater company plans to hire people to build a stage set. The work time, T, in hours per person, varies inversely with the number of people hired. Okay, so we can say that T equals K over P. The company estimates that 25 people working for 300 hours each can complete the job. Okay. So that'll be 25 people time. So it'll be 300 is the time. 25 is the number of people. So by filling in those 2 points, those 2 values, we've got something in which K is the only thing we don't know, so we can solve, right? Multiply both sides by 25. And now we know that our K equals 25 times 300. Let's see, 3 times 25 is 75, so it's got to be 7,500. So here's our updated inverse variation. T equals 7,500 divided by P. Okay, now third step, answer the question. Find the work time per person if the company hires 30 people. Okay, so T equals 7,500 divided by 30. And let's see. I guess I'll bring up my calculator. That's no good. Second plus 7, 2. 7,500 divided by 30. 250. All right, so it'll take 250 hours per person if they hire 30 people, right? So you could see as one number goes up, the other one goes down. Okay, well that is the lesson. Let's review our objectives. Given a situation, including a real-world situation, determine whether a direct or inverse variation exists. Kind of did that. We could have had a better example of a real world. We did do some real-world problems, but we definitely looked at our tables of value and determined whether it was direct or inverse. Write an equation for a direct or inverse variation. We've done that. Graph an equation representing a direct variation given a set of data. And while that is one of the SOL objectives, I consider that we've already done that, right? We've already done that. That was what we did a couple of units ago. So the homework comes from 2 pages. The first page is just about direct variations. The second page is about direct and inverse variations. It's a lot of problems, definitely. There are no odds. It's all, okay? But a lot of these, like 3 through 6 and 3 through 14, it just say whether it's direct or inverse or neither. I mean, those should go really quickly. And some of these, again, I'm kind of following the pattern of giving you an even and an odd. The odd you can check in the back of the book. Make sure you get the concept and then try to do the even and be ready to, talk about it in class the next time. I believe this 33, 34, and 35. Remember that in the book, when they have one problem and it's circled like that, then That's not going to have an answer in the selected answers section in the back of the book. Instead, you look for the worked out solutions, which I think is a little further back. Okay, so you're going to get one which has a worked out solution, and then another odd number which has an answer only, and then you'll have an even number which will be up to you to figure out. And I believe this is the word problem right there. Okay, so good luck, and if you're in 1A and you only got a 30-minute lecture, I hope you went back and looked at this to kind of get yourself caught up.